Right. So last class, which was on Tuesday, all the way back then, we finished definite integration, right? Like all the rules and all that. And we started, okay, well, now we're going to start application of definite integration. So just to show you what we did last time. This is what we did. Talked about the rule. F prime is another way to represent the differential of a function. We talked about that. This is the definite integration rule. We said that definite hold on, sorry. We said that definite integration produces a value, unlike indefinite integration, where you got an expression. This one gives you a value. So you're actually going to get a number, right? And we talked about the upper and lower limits. That's how you can differentiate. That's how you can differentiate between definite and indefinite integration. Definite integration has the upper and lower limit. Indefinite integration does not. Indefinite integration, you have to include the arbitrary constant, c, so you would always put plus c. Definite integration, you don't do that. Why? I showed you this whole thing as to why we don't put the plus c. It's because they cancel, right? So definite integration, there's no arbitrary constant. Let me show you. These are some rules that you're required to know. Yeah. We went through that. And we did all of these questions. All of these here, they were past paper questions, right? So yeah, these are all the past paper questions on definite integration. You don't need to worry about doing that because we just finished it. Right. Now to what we're doing today. Application of definite integration. Definite integration can be used to find the area under a curve, to find the volume of a solid, and it's also used in kinematics. But what we're doing today, what we're focusing on is area under a curve. So for your exam, you're required to know how to find the area of the region in the first quadrant bounded by a curve and the lines parallel to the y-axis. So maybe some people, understand what this sentence just said. Others, you may not understand what's going on. That's okay. I could draw it out for you so you can get to see what it looks like. That's my visual learning. So just note that this is how you find area under the curve. This is the formula you have to use. Area under the curve. A is usually denoted by A, right? Is equal to the integral of f of x dx, and the upper limit is b, lower limit is a. The units, because it's area, you have to put units squared, or if they gave you a unit, for example, they told you that it's in centimeters, you need to put centimeters squared, right? Because it's area. So let me just show you what that looks like. Area of the region in the first quadrant bounded by a curve and the lines parallel to the y-axis. Let me show you what that looks like real quick. Just say I have, my Cartesian plane. Sorry. Y. Come on. X. So for this particular topic, for your exam, we're dealing with the first quadrant. So remember, this is the first quadrant, second quadrant, third quadrant, fourth quadrant. We did that when we were doing trig and solving the equations and all that. To say you're given a curve, let me just draw a parabolic curve. So that's the curve we met when we were doing quadratics, right? This is my curve. Yeah, nice, simple curve. And what this topic is about is finding the area of the region bounded by the curve and two lines parallel to the y-axis. So what does that look like? Parallel to the y-axis. this vertical axis right here is my y-axis. So let's say I drop a vertical line here, going all the way down to some x value. Let me just, hold on. Why is this doing so long? I don't know. It's kind of distracting. Right. I dropped the vertical line here. It's parallel to my y-axis. Two parallel lines, right? And let me just name the value. So the x value here is going to be 8. If I do another, I drop a line parallel to my y-axis, and I name this x value b. What we are trying to find by applying our knowledge of definite integration, f of x with respect to x of dx, upper limit is b, lower limit is a. Using my knowledge of definite integration and all the rules that I know and all that, I could find this area right here, area under the curve. So in the first quadrant, a curve, and it's bounded by two lines parallel to the y-axis. So what does this rule help me to find? It helps me to find this green area right here. Using definite integration, I'm able to find this green area. Let me just label it area. A for area. You understand that? Yes? No?
Yes, miss.
Yes, miss.
Yes, miss.
So it's the area bounded by a curve and two lines parallel to the y-axis. So let's say my curve didn't look like that. Instead, it looks like this. Let me use. This is still a curve, and I can still find the area under this curve bounded by two lines parallel to the y-axis. Let's say this line is parallel to the y-axis. So let me say this is my upper limit, and my lower limit is actually along the y-axis. So this is the. I can use my formula to help me to find this area right here. Yeah, come on. Come. I can use my formula to help me to find this area right here. So area bounded by a curve, which is the blue line, well, the blue curve, and two lines parallel to the y-axis. A is my lower limit because it's the lower number along the x-axis. We know along the x-axis it starts from 0 and it goes all the way up. So it'll be 0, 1, 2, 3, 4, whatever. So A is the lower number, B is the higher number, right? And then using this formula, I'm able to find the area under this curve. So this green area right here. And that's basically what you have to do. Just follow the rule and you're good to go. Remember your unit. If they did not give you a unit, it is always unit squared. If they did, whatever unit that is, squared. So if they give you meters, your answer should be, let's say I did all this and my answer came out to be 36. I need to put 36 units squared if they didn't give me a unit, or if they specifically told me that the area is in centimeters, then I need to put centimeters squared. If they told me it was in meters, I would put unit squared. How many units though? Meters squared, etc. So everybody good with this, right?
Yes, miss.
Yes, miss.
All right. Well, let's apply this now. Let's do some questions. So like I said, definite, well, integration. This whole calculus thing with, oh my, why is this thing? Anyway, this whole section, introduction to calculus, it's all about using the rules, well, knowing the rules and applying the rules. once you know the rule, so how do you find area under the curve? You know you have to follow this rule. Just follow the rule and you're good to go, right? Not rocket science. So let's practice. Now, I'll do the first one with you. So can you just copy down the first question and let me know when you finish, please? You finished writing down this question?
Yes, Miss, I have it now.
Yes, miss.
All right. Well, let's go through it then. Like I told you, this is so easy once you know the rules. So they ask you to find the area. The first thing you need to recall is the rule. So area, remember I told you, can be denoted by A, is equal to the integral of f of x dx. My upper limit b. Oh my, bro, come on. And my lower limit is a. So once they ask you to find the area under the curve, bounded by some lines, you know this is what you're applying. This is the rule that you're applying every single time, right? So every time you see a question like that, you know this is what you're gonna do. So what did they tell you? What information did they give you? Well, they told you that your curve y is equal to 2 cos x plus 3 sin x. And they also told you that the boundaries, you see those two vertical lines I was showing you that were parallel to the y-axis, those are called your boundaries, right? Vertical boundaries, because they're vertical lines. Yeah. They told you that x is 0, and then they also told you x is equal to pi on 3. So just to show you what that looks like, this isn't what you see this curve right here? But I'm gonna draw, hold on, let me just show you what we do it up here. So that's my y-axis, my x-axis. Let me say this is my curve. This isn't really what this curve is gonna look like, because this is a parabolic curve. This is just, to help with your understanding. Let's assume this curve looks like this, right? Remember the drawing. You have your lower boundary parallel to the y-axis. I name this A. Like the value of x at this point right here is A. This is my next boundary. This is B. Our aim is to find the area under this curve. This is what we're trying to find. So like I said, see this curve right here? This is not what this right here would look like, right? It's just to help with your understanding. All you need to know, we're trying to find the area under the curve bounded by these two boundaries, right? So all you need to do, apply a rule. In this case, x equals 0, and x is equal to pi on 3. 0 is the lower number, and therefore my value of a in this case is going to be 0. The next one, pi on 3, that's the bigger number, so b, which is my upper limit, is going to be pi on 3. From there, all you need to do, apply your rule. So a is equal to the integral of f of x. F of x would be the cube, right? So in this case, we trying to find the integral of 2 cos x plus 3 sin x. This is with respect to x, so we put the dx. My upper limit, I just said, is pi on 3 because that's the bigger number. My lower limit is 0. And from here, all you need to do, you see what we were practicing last class with the definite integration. Hold on, summation again. You see what we were practicing last class with definite integration. First, you need to integrate this expression here, and then you substitute the upper limit, you substitute the lower limit, you subtract the both. That's all you have to do now. It's really simple, right? Is everybody following so far? Yes? No?
Yes, miss, I am.
Yes.
Okay, let me have one more person answering.
Yes,
You understand?
miss.
Okay. So, like I said, all you do now, what we were practicing last week, was it? Yes, last week, with the definite integration, that's what you're going to do. First thing, integrate this expression right here. So how are we going to integrate this expression? I'll just give you a bit. Try integrating this by yourself and let me know what you get. You know, we need to keep practicing this. So integrate this expression right here and let me know what you get. Yep, that's correct. So when I integrate this expression right here, I'm going to get 2 sine x minus 3 cos x. Remember, there's no plus b because this is definite integration. Then we put your little bracket there, put your upper limit, lower limit, and from here, what you need to do, take this upper limit, like we were doing before, take this upper limit and substitute it into your expression. So wherever you see x, you're going to replace it with your upper limit, then you're going to do the same with the lower limit, subtract with both, get your value. So I'm just going to erase the top here so I can do it with you. Erase. Wait, whose camera is on? Well, I can't even see who's that. Anyways, somebody's camera's on. So everybody just check. Wait, chat. Wait. Please allow us to screen. Oh, shucks. Sorry. Oh, okay. Next time I'll wait. There's no undo button, so I can't undo that. Not mine. Somebody's camera's on there, so I don't know. Unless you want it to be on, well, that's fine with me. Okay, we're applying what we know about definite integration. We take this upper limit, substitute it into the expression. So let's do that first. So my first bracket is going to be, oh gosh, wait by my dad. Anyway, 2 sine, wherever I see x, I'm going to replace it with my value of the upper limit. So that's pi on 3 minus 3 cos, wherever I see x, I'm going to replace it with this instead. That's my first bracket, minus, then I'm going to do the same with the lower limit. So wherever I see x, I replace it with 0. 2 sine of 0 minus 3 cos of 0. All you need to do now, find the value of this bracket, find the value of this bracket, subtract them, get your answer, right? I was telling you last class, just because the value 0, like I substitute the value of 0 into this, does not necessarily mean that the value of this bracket is going to be 0, right? This isn't 0 supposed to be first? What do you mean? Like, if I'm supposed to put 2 sine 0 minus 3 sine 0 minus 2 sine whatever, blah, blah, blah. So substitute 0 first and then substitute the pi and 3. Is that what you mean? Yeah. It's usually the upper limit than the lower limit. Because if you subtract the lower limit, so okay, let's find the value of this, and then I'll do it again to show you what would happen if I put the 0 first and then pi and 3. So does anybody have an answer for me? What is this value right here? Exact values, right? Don't give me any decimals. Okay, somebody tell me quick. What's the value of sine of pi and 3? Anyone else having this? The session keeps kicking me. Oh my. Sorry. I don't know what's going on. Somebody tell me quick. What's the value of sine of pi and 3? You should know this. Pi on 3. Pi on 3. Sine of pi on 3. Come on. Anybody? Anybody? I'm not gonna move on until somebody tells me. Yeah? Yeah, it's true. 3 on 2. You need to know this, right? When we finish this question, I'll show you like a little trick to remember them. So the value of sine pi on 3 is root 3 on 2 minus 3. Cos of pi on 3, what's that value? Anybody? Come on. You need to know this for your exam, right? Aha, it is aha. Okay, so this is my first bracket. I need to find this value. My second bracket now. This is minus sine of 0. What's the value? Zero. Sine of 0 is 0. Minus 3. What's cos of 0?
1.
1. So that's why it's really important, not for you to assume, okay, I'm substituting 0, automatically the value in the bracket is 0. No, especially with trig functions, cos of 0 is 1. So this value, the value of this bracket will not be 0. Bro, what is wrong with them? Anyways, yeah. Finding the value for this bracket, these 2's will cancel, so I'll end up with 3 minus 3 on 2. So I need to find that value. 2 by 0 is 0, then minus 3, but minus 3 and a minus 10 is plus 3. What's root 3? Okay, what's this whole value here? Just put it into your calculator. Or you could actually give the, anyways. Put it into your calculator and tell me the value. Anybody has a value for me?
Square root of 3 plus 3/2.
Wait, repeat.
The square root of 3
Mm-hmm.
plus 3/2.
It's 3 over 2. Okay. Well, yeah. For the exact value, you can put it like this. If they ask you for an exact value, yeah. Or they say like leave it in fluid form. So 3 plus 3 and 2. Remember unit squared. But since they didn't, specifically ask you to leave it in fluid form, or they didn't ask for the exact value, you could put the decimal. But can anybody tell me what's the decimal? This as a decimal. Anybody? Yeah. So just put it 3 significant figures. The answer is gonna be this. So you leave the exact value. Remember unit squared, or you could put the 3.23 unit squared. Everybody good with that? Yeah? No?
Yes, miss.
Okay, let me just see something real quick. What's up? So in case anybody was wondering, Jana told me that she gets it, but in case you're wondering, how come I didn't put 0 first and then the pi and 3? Well, if I do that, the value in this bracket right here is minus 3, right? Then that's going to be subtract whatever value is in this bracket. And now what's root 3 minus 3 and 2? That minus or minus is going to give me a plus, right? So it's minus 3 plus 3 and 2, which is going to give me minus root 3 minus 3 and 2. The problem is that, see these minus sign, well, not necessarily this one, but you see this minus sign right there, that's kind of a problem. You don't really do that. That's just not the standard way to write it. So don't do that, right? Upper limit, subtract, lower limit. Okay. This technically isn't wrong because there's a rule. If you go back to the rules that I showed you for definite integration, there's one that states if my limits are switched, so instead I put A, then B, and this whole f of whatever, then my answer is going to be negative. So I mean, technically it isn't wrong, but it isn't the standard way to do it, right? Do put the upper limit, then the lower limit to get a positive value. Just in case anybody was wondering. So can I clear this now? Yes, no? Is it okay if I clear the screen? Okay.
Yeah.
All right. And like I said, I'll show you a way to remember the special angles. So the first way, let's say I have like a little, look at me. Pinky finger. Oh my, look at that. Artist. Anyways. Wait, how much time do I have? Oh gosh, wait. I need to restart this meeting. So rejoin.
I think the session ends at 30 minutes now. It decreased to 30 minutes.
I have a little over 1 minute left. That's the dude.
Wait, wasn't it 40 minutes a session?
Yeah. We started a while ago though. Who's talking to me? Oh nah. Okay. We have less than a minute. Rejoin, okay? No. Unless you